Hello and morning and welcome to this morning broadcast, this live stream even, on the OCR paper for Foundation GCSE Maths. This is paper 2 today that we're doing. Let me just, this is paper 2 that we're doing today. And this is for OCR. The paper 2 is the non-calculator paper. So for AQA and Edexcel, paper 1 is the non-calculator. But for OCR, they have paper 2 as their non-calculator. So if you're doing this video with me, you do not need a calculator. I have put a link to paper 1. I did a video the other day for paper 1 that is in the description if you want to have a look at that. Other than that, I will just begin. Okay, so we'll look at the questions and then I'll answer them. And you can pause the video if you want to have a go, or just kind of watch along and then have a go at the paper again later to see if you've remembered. Okay, if you do struggle with any of the topics as well, I'm going to stick around at the end of this video to answer any questions that you might have. So just put them in the chat and we can discuss them then. And if there are any topics that you need support with, I do also have a website. My website is called crackmaths.co.uk. Here it is here. And in this section, what you can find is you've got resources. I've got these tutorials here which cover it says functional skills in 70 sessions. So basically, functional skills level 2 is another qualification that you can take, which gets you the equivalent to a pass at your GCSE at grade 4. If you don't pass your GCSE, it's actually a really good option because its entire contents takes up half of the GCSE curriculum. So anyway, so these first 70 sessions here, these are the overlap of that. So these cover the Foundation GCSE, and they also cover the functional skills tutorial. And then after that, what you'll want to do is you'll want to go to the tutorials on my website which say GCSE only, and this covers the material up to the end of the foundation paper, so the end of the foundation curriculum. Unfortunately, this section is still under construction as I am working to make the videos as quickly as I can, but they take a little bit of time. So whilst I'm building this, you can have access to what's here. If you click here, you can see there's topics like here, understanding mathematical symbols. You'll have the questions in places like this, which you can have a go at. And then at the end of these, you've got the answers. And then if you were ever confused by any of those, I've also been doing these videos as well here, where I have worked through all of the questions as well. So you can have a go there. So yeah, anyway, let me pause that. And then we should actually get on with the exam paper, because that is what the purpose of this video is. So let me find this. Let me do this here. And yeah, here we go. Let's begin. So question 1 I have here, which is work out 45 times 100. So that's going to be 4,500. The best way to think about it is if you're multiplying a whole number by 100, you just add on the 2 zeros. This one here is 37 divided by 100. This is a little bit more challenging. So 37 divided by 100, I'll write 37 here. I'll put a decimal place at the end here. Now, when we divide, we move the decimal place once for every 10. So it's once if we were dividing by 10, twice if we were dividing by 100. So the decimal place is going to move here, which means I'll need to put a 0 here. So the answer to B is going to be 0.37. Okay, question C. What we have is we've got 2.36 plus 1.79. So I'm going to put these together using the column method. So I'm going to write one on top of the other. So I'm going to go 2.36. And then underneath, I'm going to put 1.79. And now what I'm going to do is the main thing that I've done here is I had to make sure that the decimal points were lined up, because now what I can do is I can just do my column method normally. So what I'll do here is 6 add 9 is 15, so I'll put a 5 here and a 1 here. 3 add 7 is 10, so add the 1 makes 11, so I'll put a 1 here, put my decimal point down, carry the 1, and then I've got 2 add 1 here, which is 3, and then with the other one makes 4. So the answer to this one will be 4.15. Okay, right. Next bit here, we've got the question part D, which is 0.82 take away 0.36. So again, I'm going to use the column method, and I'm going to line up the decimal points because that's the most important thing. So we've got 0.82 take away 0.36. So first of all, what I'm going to do is I can't do 2 take away 6 because 6 is larger than 2. So what I'm going to do is I'm going to split this 82 up into 7 and 12. So this is now like 70 add 12, which still makes 82. But it just means that we can do 12 take away 6. So 12 take away 6 is 6. 7 take away 3 is 4. And then I can put my zeros here. And there we go, that's the answer to that, 0.46. Okay, right, let's take a look at the answers, just to check that these are correct, because we can always go wrong. Okay, so here we go. So let's scroll down. Where are we at with the answers? Here we go. Oh, 1 second. I'll just move them so that they're on the screen. So here we go. Yep, 4,500, 0.37, 4.15, and 0.46. Brilliant. So they were all correct. Let's move on to the next round. So here we go. Right. Question 2A, part 1. Write down 50% of 80. Well, 50% means half, so we're looking for half of 80. Half of 80 is 40. Okay. Next part, we've got part 2 here. We've got use your answer to part A to complete this statement. 50% of 80 is the same as what percentage of 160? Okay, well, it's going to be 25% of 160. Because, well, yeah, what we've got here is we've got 40. Well, we're kind of looking at 40 out of 160 for that. So 40 out of 160, which is 4 out of 16, which is equal to 1 over 4, which is a quarter. And a quarter as a percentage is 25%. Okay, so let's have a look at part B. Part B says, write 36 as a fraction of 120. Give your answer in its simplest form. Okay, so this just means simply 36 over 120. But now what we have to do is we have to put it in our simplest form. Now, I always find the easiest way to do this is just to keep dividing by the smallest number possible, unless you spot something which really works. Actually, I have spotted something that really works for this one. Both of these are clearly divisible by 6, okay, because I know that 120 divided by 6 is 20. 36 divided by 6 is 6. So now what we're going to look at, we've got 6 over 20. Now I'm going to halve this because both of these are still even numbers, so I can divide both of these by 2. So when I halve this, this becomes 3 over 10. Now 3 is a prime number, so I can't simplify this anymore. So I'm just going to write 3 over 10 as my answer here. 3 over 10. Right, next part we've got here, question 3A, which is work out 2 over 3, add 2 over 3. So what we're doing, we're adding thirds together here. So we're adding 2/3 to 2/3. So the question is, how many thirds do we have? If we've got 2/3 add 2/3, well, that gives us 4/3, okay? And this is the principle for adding fractions, which is you add the top numbers, but not the bottom. But the bottom number must be the same, because otherwise you're not adding the same thing together, okay? So here we go, 2/3 add 2/3 is 4/3. Part B here, let's have a look here. Work out 1 quarter divided by 1/8. Okay, now, in order to divide by a fraction, what we do is we flip the second number and we then just multiply. So 1 over 4 divided by 1 over 8 becomes 1 over 4 multiplied by 8 over 1. Now with fractions, when we multiply them, we can just multiply across. Okay, so what we're going to do is 1 times 8 is 8. 4 times 1 is 4. So now what we're looking at is we're looking at 4 over 8. Well, 4 over 8 is 8. No, not 4 over 8. We're looking at 8 over 4. 8 over 4 is 8 divided by 4. So 8 divided by 4 is 2. So the answer to this question would be 2. Okay, right. So I'm going to quickly take a look at the mark scheme for this page to check that we've got it right. Just remember our answers here. So we had 40, 25, 3 over 10, 4 over 3, and 2. So let's see how they went down. So here we go. 40, 25, 3 over 10, 4 and 1/3, or equivalent. They've said mark M14. Oh dear. Right, 1 second, I missed something. Let me just show you. Look here, it says give your answer as a mixed number. Okay, so just to quickly change that, what we've got is, if we're giving this answer as a mixed number, 4 over third, well 4/3 means 4/3, so let's think about thirds here. So 3/3 makes up a whole, and then we've got 1/3 left. Okay, so we've got 4, we've got 1, and 1/3. Okay, always be careful when reading your questions. Right, let's continue with the mark scheme. So here we go, we've got, and for this last one, we've got 2 as the final answer there. Okay, right. Let's move on to the next page. So here we go, we've got the bar chart here, which shows, the bar chart shows the rainfall in milliliters, in millimeters even, for a city in the first 3 months of the year. Okay, right. Write down the amount of rainfall in February. Okay, so here we go. If we read up to February, we can see up here. And then if we go across, we can see we're at the halfway point between 30 and 40. Well, halfway between 30 and 40 is 35 millimeters. Okay, so let's have a look at the next bit. Write in its simplest ratio the amount of rainfall in February to the amount of rainfall in March. So let's take a look. So in February, we had 35. Okay, I'll just put this up here for the time being. And in March, we had, if we read up here, and then read across, that's 55. So we've got 35 to 55. They want us to simplify this, so we've got to work out what we can divide these by. So I can see they both end in 5, so they're both divisible by 5. 35 divided by 5 is 7. 55 divided by 5 is 11. 7 and 11 are both prime numbers, so what I'm going to do here is I can just write down 7 to 11. Okay, there we go, and that's that bit done. Right, part C says the total amount of rainfall in January and February is the same as the total amount of rainfall, the total amount of rainfall in March and April. Work out the total amount of rainfall in April. So right, so let's have a look at here. So we need to find out the total in March and February. So March is 70, and then we want to add on the 35 from February. Okay, so I can do this over here. So we've got 70, add 35, 0 add 5 is 5, 7 add 3 is 10. Okay, so there's 105 millimeters of rain in January and February. Now in March, there was 55. Okay, but we need to get up to 105. So what we want to do is we want to do 105 minus 55. You might see what this is. I'm just going to work through it anyway. 5 take away 5 is 0. Well, 0 take away 5 we can't do, so we just move this 1 over and think about this as 10 take away 5. 10 take away 5 is 50. So there would be 50 millimeters of rain in April. So let's write that down here. 50. Okay, right. Let's check our answers. Okay, so here we go. Over to the mark scheme. So we have got 35 correct, 7 to 11 correct, and 50 also correct. Perfect. Right, let's move on. So, oh, no, that's ChatGPT. It looks very similar to this button here. Right, so here we go. Right, let's move on to the next one. So question 5 is complete the 3 missing values on this multiplication grid. Okay, so we've done -4 times -5 gives us 20. Yep, that's correct, because negative times negative gives positive. Okay, so minus 4 times 9 will be, well, 4 times 9 is 36. So 1 negative means the answer will be negative. So that's minus 36. Now, 9 times something gives minus 54. Well, 9 times 6 gives 54. So this will have to be minus 6. And then minus 6 times minus 5. Well, this is just going to be the same as 5 times 6 because it's double negative. So minus 6 times minus 5 is going to give us 30 because 5 times 6 is 30. Right, let's have a look at question 6. This one says that 3 adults, Amos, Beth and Charlie, are comparing their ages in years. Amos is 32, Beth is 48. The mean of Amos, Beth and Charlie is 50. Work out the age of Charlie. So the mean we find by everything added, divided by number of things. Okay, and we know in this case that's equal to 50. So let's see what we can do. We don't know what everything added is. We'll just actually rename that total. We do know the number of things, which is 3, and then we know that this equals 50. So something divided by 3 equals 50. Well, in order to work out, if we rearrange this calculation, the way that we do this is if something divided by 3 equals 50, then that means that these two numbers, the 50 and the 3, will multiply to give this total. Okay, so 3 times 50, well, it's going to be 3 times 5, and then you add a 0. So 3 times 5 is 100, is 15, and then add the 0 is 150. So Amos, Beth and Charlotte add to make 150. So let's work out what Amos and Beth add to start off with. That's going to be 32, add 48. So 32 add 48, well, 2 add 8 is 10. 3 add 4 is 7, add 1 is 8. So here we go, Amos and Beth equal 80. All together, they equal 150. So we now just need to do 150, take away 80, and find out what that is. 0 take away 0, fine. 5 take away 8 we can't do, so let's just look at this as 15 take away 8. 15 take away 8 is 7. So Charlie has to be 70 years old. I hadn't predicted that Charlie would be so much older than Amos and Beth, but actually we should have known because the mean age was so high. Right. Question 7. Which is smaller? 65% or 16 out of 25? Right, well, what I'm going to do is I'm going to play with this 16 over 25. So 16 over 25 is equal to 32 over 50, okay, which is then equal to 64 out of 100. Okay, 64 out of 100, this means 64%. Okay, there's always usually some kind of little trick in the non-calculator paper that would stop you having to do such a crazy calculation as 16 divided by 25. But that was one method of doing it there. That was a nice little trick there, because if you double, then double again. Percentage means out of 100, so that's there. The other way you would have done it is 16 divided by 25, which would have been to use long multiplication. So you'd have to put, well, the divisor is the 25, so you'd put the 25 on the outside, your 16 in the middle, and then you'd just have to work through it that way. So 25s into 1 don't go, 25s into 16 don't go. Then you're looking at 25s into 160. 25s into 160, well, we've got 25, 50, 75, 100, 125, 150, 175. So they go in 1, 2, 3, 4, 5, 6 times, which confirms with this. 160 take away 150 leaves us with 10. So I'll put a 10 here, and then we can see we've got 25s into 100, which goes 1, 2, 3, 4 times. Okay, great. Right, let's... we need to write our definition here. So we will say 16 over 25 is smaller because it is equal to is equal to 64%. Okay, I'll be back 1 second. Okay, sorry about that. Let me continue. Oh, 1 second. Let's first mark these questions. Okay, so let's get the mark scheme up. Okay, so we had, minus 36, 30, and negative 54. Great. We had 70. Perfect. And we had 64. Wonderful. Okay, great. So let's continue on with the next page. Okay, so the next one is complete each statement. So 24.2 divided by 0.5 equals... dividing by 0.5 is the same as multiplying by 2. Okay, I can just show you that with a fraction. If we were thinking before, if we're thinking about 24.2 divided by 0.5, which is a half, if you remember, dividing by a fraction is the same as multiplying by its reciprocal. So this would be like 24.2 times 2 over 1, which is like just 2. So here we go. Oh, I put a 5 there. 24.2. So what I've got to do is if I'm dividing by 0.5, that's the same as multiplying by 2. So 24.2 times 2. Well, this is quite easy. They all just kind of double because it doesn't do anything funny. So this is going to be 48.4. Now this one here, something times 4 equals 12.8. Okay. So now if two things multiply to give a third thing, which we call the product, in order to find, the truth is that this number here, the product, divided by either of these two things will give us the other thing. So what I need to do is if I divide this 12.08 by 4, that's going to give me the answer here. Just to show you a quick example, if I had something like 2 times 3 equals 6, well, I know that either 6 divided by 3 equals 2, and 6 divided by 2 equals 3. Okay, so this is how that works. So what I can see here is that what I need to do is if I do 12.08 divided by 4. Okay, I'm going to do this in 2 steps because I feel like it. So 12.08 over 4, I'm just going to half it first. So that's going to become 6.04 over 2. And then I can half this again. Okay, so that's going to become 3.02. So the answer to this would be 3.02 times 4 is 12.08. Okay, I'll leave my working out there because that's important. 9a says the 4 apples cost 180. Find the cost of 5 of these apples. Okay, so this is a direct proportion question. So if we've got 4 apples equals 180. Okay, well, I can say that 2 apples will equal 90p because that I've divided this by 2. So this is half of that, this is half of that. I could then go down to 1 apple. So 1 apple will equal half of this again, so divide that by 2 again. So half of 90 is 0.45. So here we go. And now I know that 4 apples cost £1.80. 1 apple costs 45 pence. So to get 5 apples, what I can just do is I can do £1.80 add the 45p. So here we go. We've got 0 add 5 is 5, 8 add 4 is 12, and then 1 add 1 is 2. So the cost of the 5 apples would be £2.25. Okay, right, let's have a look at the next bit. So we've got here part B, and part B says, by rounding each value to one significant figure, estimate the cost of 8.2 kilograms of bananas at 73p per kilogram. Okay, so we've got to round this. So 8.2 to one significant figure becomes 8, and 73p per kilogram becomes 70. Okay, right, so these are what the two numbers are going to go to. Now what I've got to do is I've just got to think about the cost of these things. So what do we have here? We've got here, by rounding each value to one significant figure, estimate the cost of 8.8 kilograms of bananas at 70p per kilogram. Okay, so this is what I'm now looking at. 8 kilograms of bananas at 70p per kilogram. So that means that 1 kg equals 70p. Okay, and then I want 8 kg. Okay, so I need 70p times 8. Okay, right, well, 8 times 7 is 56. So 8 times 70 is 560. So it's 560p. Now, every 100p makes a pound. So this equals £5 because we've got 500. And 60 pence because, well, 560p. So the 60p is still there. So the cost of this, the estimate for the cost of 8.2 kilograms of bananas should be £5.60. Okay, so let's have a look at the answers to check that those were correct, and then we can move on. So where are we? Here we go, £2.25, perfect, and £5.60, also correct. Great. Right, let's have a look at question 10. So question 10 says, choose a word from this list that best describes the statement. We've got the words equation, expression, formula, inequality, and term. So the first one is an expression, okay, because there's no equal sign. If you see algebra just written down casually with no equal sign, that means it's an expression. Now, the next one is an equation. Okay, you could think that it was a formula because pi r squared is a formula. However, because it is equal to something, as opposed to it just saying pi r squared equals area, because it's equal to this 30, that means it is actually now an equation because it is possible to solve it. Right. Let's have a look at this next part here, and we'll then mark this round as well. So a bag contains only red, green, and blue counters. 8 of the counters are red, 15 of the counters are green, the rest of the counters are blue. Sam chooses one counter at random from the bag. The probability that this is a green counter is 3/8. Work out the number of blue counters in the bag. Okay, right, so we have to have a little bit of a think about this one. So 15 of the counters are green, 8 of them are red. 3/8, the probability that the counter is green is 3/8. Okay, right, so this is really an equivalent fraction question. So we've got here, we know that there's 15 green counters out of the total counters. Okay? And this is equal as a fraction to 3/8. So what we need to do is we need to work out if 15 was on the top, what would be on the bottom so that the fraction would simplify to 3/8. Okay, well, I know that to go from 3 to 15, if I go this way, I know it's a bit backwards, I'm going to times 5. So if I times this 3 by 5, that gives me 15. Now, the way that equivalent fractions work is you've got to multiply the top and the bottom by the same thing. So I've got to multiply this by 5 as well, which means that there are 40 counters in the bag altogether. So I know that there's 40 counters. So now my next step is going to be to work out how many of these are blue. Well, I know that 8 are red, so 40 take away 8. Well, that's going to be 32. So 8 are red, and then 15 are green. So if I take away the 15 green, so 32 take away 15. 2 take away 5 doesn't work, so I need to borrow from the 3. So we're now looking at the 3 as 20 and 12, so which does add up to 32. So 12 take away 5 is 7, and 2 take away 1 is 1. So there should be 17 blue counters. Okay, here we go, 17 blue counters. And that should be the answer to 11, hopefully. Okay, let's go over to the mark scheme and see if that's correct. So here we go. So we've got expression, equation, and 17. Perfect. Okay, right. Let's have a look at this next question. Okay, so here we go. It's question 12 here. And it says, the diagram shows two straight lines crossing a pair of parallel lines. Find the value of x. Give a reason for your answer. Okay, right, so, oh my gosh, what have we got here? So, right, let's just start filling out what we can. Well, actually, I'm going to just highlight the parallel lines here because that's important, okay? And then, actually, for this first part, I can see what the answer is. If I draw this line here, we can see that we have got this angle here, the x, in an alternate position with this 59. So x will be 59 because of alternate angles in parallel lines are equal. Okay, so that's the first one. Now let's have a look at this second part here. So the second one says, find the value, oh, I almost moved off the screen. Find the value of y, give a reason for your answer. Okay, so y is up here. So this is y. Yes, okay, right. So let me change my colour of my highlighter. Okay, so let's go here. So we're now looking at this line for y. And this is the 42, and this is this bit here, this is the y. So these two angles here, this bit here and this bit here, these are corresponding, okay? Because basically, if I draw this section out here, if I draw it like this, and then I move this, oh no, wrong thing. And then I move this up to here, what I can see is the situation at this line is identical to the situation at this line up here. And that is what a corresponding angle is. So y is corresponding to 42 because the parallel lines mean that the situation is the same. Okay, so let me write that down here because that will be our answer to this question. So we've got y is equal to 42 because it is corresponding with the 42-degree angle because of the parallel lines. Okay, right. So the last part of this question is to find the value of z. Okay, so z is here. Now, let's see what we've got. So let me fill in some of the information that we've got here. So we know that the x is 59. We know that the y is 42. Okay. Now, z is here. Right, well, okay. So what I've got here is I know that if this angle here is 42, this angle here is also 42, okay? Because they're vertically opposite. So if that's 42, this bit's 42. Now, if this is now what we've got here is we've got this little triangle. I'll just draw it out here, where this angle is 42 degrees, and this angle is 59 degrees. Now, because we know these two angles here, what we can do is we can calculate this angle here, which is this one, okay? Because the angles in a triangle add up to 180. So I'm going to do 42 add 59, which will give me 2 add 9 is 11. 4 add 5 is 9, so this will be 101. So they make 101, which means this little bit here will be 79 degrees. So that's 79 degrees. Now, Z is on a straight line with this 79 degrees, okay? So angles on a straight line also add up to 180. So 79 add Z has to equal 180, okay? Which means that Z has to equal 101, because 101 add 79 makes 180. So let's do that here. Okay, so Z equals 101. Okay, was that what we said? Yeah, Z equals 101. Okay, and the working out that I did up here, I would just have actually done there, but I just put it up here because that's how the screen works. But let me cut that and put that here, just because it's important to show working out. There we go. And I'll write the answer in the mark scheme. And then I'm going to check my work. We'll check with the mark scheme to see if that was correct. Okay, so yeah, 59 alternate angles, 42 corresponding angles, 101. Yeah, that's just the answer. Okay, great. Right, let's have a look at the next page. So here we go. So question 13, we've got work out 3 to the power of 4. Now, to the power of 4 means to multiply by itself 4 times. So this is 3 times 3 times 3 times 3. So I'm just going to do the 3. I'm going to think of this as 2 lots of 3 times 3 to start off with. So 3 times 3 is 9. 3 times 3 is 9. So I'm looking at 9 times 9. 9 times 9 is 81. Right, here we go. Simplify 5x squared divided by x. Okay, right, so what I'm going to do is 5x squared is 5 times x divided by x, okay? Well, what we can do here is this is the cancelling down trick. So if we've got something that appears on the top and the bottom, we can cancel it down, because x divided by x, if I think about x over x, that equals 1. So because there was an x on the top and an x on the bottom, I can divide those out, so they become 1, leaving us just with the 5x. Okie dokie, right. Question C. Rearrange this formula to make x the subject. Okay, so, well, the first thing we've got to do is get rid of the 2. Okay, so currently we've got this situation where we're saying y equals x divided by 5 plus 2. Or, in other words, y equals something plus 2. So if y equals something plus 2, then it's true that y take away 2 equals that something. Okay? In which is the x over 5. Now, you might like to think about this. This is a common way of thinking about it, as saying that we took 2 away from both sides there. And so we've taken 2 away from the left and 2 away from the right. So we've now got y minus 2 equals 5 over x over 5. What I like to do here now is just to swap it around. Okay, we can do that because the equal sign just means that they're the same. So if y take away 2 equals x over 5 equals y take away 2. And now, if something divided by 5 equals something, okay, what we know is if we times both those sides by 5, we're left with that. So if x divided by 5 equals y minus 2, it must be true that x equals 5 times y minus 2. And we do that in a bracket like this to make sure that that is simple. We could have, if we wanted to, multiplied both of these parts by 5 to give us 5y minus 10, and that would be acceptable as well. Because I've expanded that bracket, I'm going to write here x equals 5y minus 10. That seems nice to me as a way to write the answer to that. So let's mark this to check that this is all correct. So here we go. 5x is 81, yep. 5x, yep. X equals 5y minus 10, or 5 bracket y minus 2. Perfect. Right, let's continue. Right, question 4. A sales representative and a manager discuss the graph of sales over the last year. Okay. The sales representative says, I can tell from the graph that over the last year, sales have risen every month. Is the sales representative correct? Give an answer for your reason. Well, they're not correct because here the sales didn't rise and here the sales dropped. Okay, so what we can say is no. And the reason is because in June and July, sales were the same. And in August, they dropped. Okay, right, let's see what the next bit says. The manager says, I can tell from the graph that sales are now more than double what they were at the start of the year. Is the manager correct? Okay, so let's see. So here this is difficult. Okay, right. This bit is at 2 squares high. And this bit is at 5 squares high. So, in theory, I need to check with the mark scheme here because I don't know how this is going to go. In theory, judging by the graph, it does look like the sales at the end of the year are more than double what they were at the start. However, we have no scale here. Okay, so say for example, they had done one of those like zigzaggy things and this had started at 10. So therefore these squares wouldn't make the same difference. So what I'm wondering is this question about making us aware that they haven't put a scale on the side, or is this question about recognising that this is more than twice as high as this? Okay, so let's take a punt and say no, because there is no scale on the side. There is no scale on the side. So we do not know the values. Okay, I'm nervous about this. It might be wrong. Okay, so let's have a look. I think this is a mean question. Right, anyway, let's have a look at the answers to see what they've said. So part 1 is correct. They've said no. Part B is correct. They've said no vertical scale numbering, so cannot see if the sales have doubled. Yes, excellent. We went with the right answer. Okay, wonderful. Right, so here we go. Question 15. We've got here, triangle A and triangle B are drawn on the coordinate grid. Describe the single transformation that maps A to B. Okay, right, so this is a reflection because I can see that, and the line of reflection is going to be here because that when things are reflected, they need to be, each point needs to be the same distance away from the line of reflection, and so that works here. Those top points are both 4. Oh, is that right? Yeah, those top points are both 4 away. These bottom points are both 2 away. The name of this line here, this line is called x equals 1, because wherever you go up or down this line, every single value on this line is given by x equals 1. Okay, so that is the name of that line. So if I'm to describe fully the single transformation, I'm going to say it is a reflection over the line x equals 1. Okay, great. Right, let's have a look. Oh, well, let's mark. Oh, maybe there's more. No, no more to that page. Let's quickly check that that is correct. Okay, so here we go. Reflection in line, x equals 1. Perfect. Okay, here we go. Back onto the next one. Question 16. So question 16 says, here are the first 5 terms of a sequence. Write down the next term of the sequence. Okay, so 4, 8, 12, 16, 20. It's going up in 4s, so the next term will be 24. Okay, Kai says all of the terms in the sequence are even numbers. 402 is an even number, therefore, if the sequence is continued, 402 will be in the sequence. Okay, give your reason for an answer. And the answer is he correct? No, because the sequence is the 4 times table. Is the 4 times table. Okay, so it includes 400 and 404, but not 402. Okay, right. Part B. Here are the first 5 terms of another sequence. So we have 0.25, 0.5, 1, 2, and 4. Write down the next term of the sequence. So what's happening here? So 0.25 to 0.5, 0.5 to 1, 1 to 2. So this is a doubling sequence. So each time here, the term is being doubled. Okay, so the next term will be 8. Explain how you worked out your answer. Doubled the previous term. Okay, there we go. So that's that. Now let's have a look. Yeah, that's all the questions done on that page. So let's get these marked. So the first one was 24. No, because 402 is not a multiple of 4. Yep, that's the same thing, not in the 4 times table. Next, 8. And this one says multiplied by 2 or equivalent, which means doubling. Okay, wonderful. So let's go on to the next page. So here we go. Ooh, it's a long one. Okay, so what we've got here is we've got a motorist wants to buy a new car but does not have enough money. The price of the car is £16,000. The motorist sees this notice for a deal on the car they want to buy. The number of equal monthly payments is hidden. So pay 15% of the price of the car now and then equal payments of £300. Work out the number of monthly payments if the total cost of the car to the motorist is £17,400. You must show you're working out. Oh no, right, okay. Oh my gosh. So let's have a think about this. So pay 15% of the car now and then equal monthly payments of £300. Work out the number of monthly payments if the total cost of the car to the motorist is £17,400. Okay, so first of all, what we need to do is we need to work out the 15% of the cost that he pays straight away. So we know that 100% of the car is this £16,000. So 10% of the car would equal £1,600, and 5% of the car would be half of this again. So that would be £800. So 15% will equal our 10%, add our 5%. Okay, so that's going to be 1,600, add 800. I'm actually going to write that underneath like this because that's an easier way to add these things. So 1,600 add 800, we've got 0, 0, 0, 0, 0, 0. 6 add 8 is 14. Okay, 2,400. So that's how much he's paid so far. I'll be right back. Okie dokie. So where are we up to this? Right, we know that he's paid 2,400 already. So he pays a total of 17,400. So we can do 17,400, take away what he's already paid, which is nice. That's going to leave us with, well, that goes, 5, 1. Okay, so that leaves us with £15,000 for him to pay. So we know that in 1 month he pays £300. Okay, that's from the question here. So in 1 month he pays £300. So we need to work out how to get from 300 to 1,500. So what we're trying to work out is, what are we timesing this by? Because if we work out what we're timesing that by, that will give us the number of months. Okay, so we've got here 300 times something equals 1,500 even, or 15,000. Yep. So therefore, what we need to do is we need to divide 15,000 by 300. So this mystery value will be 15,000 divided by 300. Now remember, we can cancel the zeros because it's like we're dividing the top and the bottom by 10. So cancel that, cancel that, cancel that, cancel that. So we've now got 150 divided by 3. So 150 divided by 3. You might know it, but if you don't, we can use the bus stop method. Okay, so 3 into 1 doesn't go, so carry the 1. 3 into 15 goes 5 times, with a 0 up here, so that's 50. So we timed this by 50 to get to here, so that would mean that we'd have to have 50 months, okay? So there we go. I think we've answered that question now. Work out the number of monthly payments needed to cover the cost of the car. So that is 50 months, 50 monthly payments. So there we go. 50 months. Okay. Right, let's have a look to see if that answer is correct. So here we go. 50. Excellent. Wonderful. So here we go. Let's look at the next question. Okay, so the next question here says, a box contains only red, green and black pens. The ratio of red pens to green pens to black pens is 1 to 4 to 11. Work out the percentage of the pens that are green. Okay, right, so we know that when there's 1 pen in the box, there's 4, well, when there's 1 red pen, there's 4 black pens and 4 green pens and 11 black pens. So what we need to do is we need to add all those together and then kind of sort these out as fractions. So 1 add 4 is 5. 5 add 11 is 16. Okay, so 1 add 4 add 5 add 11 equals 16. Okay, now out of these, how many are green? That's 4. So 4 out of 16 are green. 4 out of 16 as a fraction can be simplified by dividing the top and the bottom by 4. So this becomes 1 over 4. Okay, so the fraction that are green is 1 over 4. Now 1 over 4 is equal to 25%. Okay, so there we go. The answer to this will be 25%. Part B says, there are 24 more green pens than red pens. Work out the total number of pens in the box. Right. Okay, so what I'm going to do here, let's draw out this ratio here. So if I've got red, let's just focus on the red to green. So we've got red to green. Okay, we've got 1 quantity of red pens to 4 quantities of green pens. Okay, which means that if there are 24 more green pens than red pens, these 3 parts of the ratio have to equal 24. Okay, so if these 3 parts of the ratio equal 24, that means that 3 parts are 24, which means that 1 part will have to equal 8, because if we're dividing it equally, that's 8, 8, 8, 8. So there we go. Each part of the ratio is worth 8. Okay, so now we know that one part of the ratio equals 8, but we also know from the first part of the question here that there's 16 parts to the ratio. So if one part is 8, we need to work out 16 parts. Okay, so we need to do 8 times 16. But that's actually quite hard, so what I might do is I'm just probably going to keep doubling, because I know that I'm going to get there. So if one part equals 8, 2 parts will equal 16, and then 4 parts will equal 32. Yep, 32. And then 8 parts will equal 64. Okay, and then 16 parts will be that doubled again, will equal 64 times 2, which is 128. So there will be 128 pens. 128 pens in the box. Okay. You could have used another method. You could have done something. You might have found it easier to do 16 times 8 like this. In fact, actually, looking at it, that might have been easier. 6 times 8 is 48. 8 times 1 is 8. Add the 2. Yeah, I think that might have actually been easier. But it's got the same method anyway. It's good to have these tricks. Okay, right. So, question 19 says, a solid wooden block has a volume of 900 centimetres cubed. The density of the block is 0.7 grams per centimetre squared. Okay, calculate the mass of the box. Give your answer in units. Okay, so, right. Well, we've got the density. Density equals grams over centimetres cubed. Okay, that's what these units are telling us here. Whenever we get a question like this, the best thing to do is to look at the units for some guidance. So what we have here is we've got the density is equal to the grams, 0.7 grams over centimetres cubed. We want the mass, okay? So what we're going to do here is we know that the density is 0.7, okay? So we've got 0.7 is equal to the mass, which is the grams, okay, over the, well, I'll replace it to mass now. So 0.7 is the mass over the volume, the centimetres cubed, which we know is 900, okay? So we know that 0.7 is equal to the mass divided 900, which means that, remember, if I've got 3 numbers like this, remember I kind of can do my 2 times 3. If 2 times 3 equals 6, then 6 over 3 equals 2, and 6 over 2 equals 3. So basically, when you multiply 2 numbers together to get the third one, whenever that number's divided by one of these, it gives you the other one. So what we've got to do is we've got to multiply these 2 things here together. So I've got to do 900 times 0.7. Okay, now I can actually play about with this a little bit, because this is the same as 90 times 7. Now 90 times 7, well 9 times 7 is 63, so 90 times 7 will be 630, and that's going to be grams. Okay, so here we go. The answer to this question will be 630 grams. Okay, right, so let's have a look at the answer to check that this section was correct. You can tell we're getting later on in the paper now because the questions are stepping up a bit. So here we go, 630, yep, 128. Wonderful. Right, so let's have a look at the next section. Here we go, we've got a table for a graph. So the graph this time, it's y equals 6 over x plus 2. So we've got y equals 6 over x plus 2. We can see what this does. So let's have a look. Well, we actually don't need to see what it does. We can just plot it because that's all they've asked us to do. I'm just going to have to shrink this a second. 1 second here. So here we go. So draw the graph of this. So we've got x is minus 6, y is 1. X is minus 3, y is 0. X is minus 2, y is minus 1. x is minus 1, y is minus 4. And then we've got here, x is 1, y is 8. X is 2, y is 5. X is 3, y is 4. X is 6, y is 3. Okay, right. So this is checking that you know about reciprocal graphs. Now, the thing about this graph is it cannot pass the value of x equals 0 because you cannot have 6 over 0 does not exist. You can't have 6 over 0. So this graph cannot cross this centre line, which is why the points look a little bit funny. But the purpose of this question is really checking that you know that, okay? Because obviously plotting coordinates is just plotting coordinates. But then what they really are giving you the marks for is for knowing that the graph will not cross this line. So if you joined these dots up any other way, they wouldn't be happy with that. They want to see that you know that this was a reciprocal graph, so it doesn't cross the y-axis, because you cannot have a fraction where the denominator is 0. Okay, right, let's have a look. Oh, 1 second. Let's mark that first just to confirm that I'm not speaking nonsense. Correct graph. Okay, that's a useful thing. Okay, that was the correct graph. So we can just move on. Okay, right. So question 21. What we have here is it says the diagram shows a rectangle with length 3 minus x and width x plus 2. So remember, these are just values. So this will have a value. It could end up being like 10 or something. This could be a value. It could be like 5. So the length of the rectangle is twice the width of the rectangle. Okay, now calculate the area of the rectangle. You must show you're working out. Okay, right. So we've got some business to sort out first. So we know that 3x minus 4 is equal to 2 times this one here. Okay, because we've been told that the length is twice the width. So say, for example, this was 3 and this was 6, then 6 equals 2 times 3. Okay, obviously it's not like that, but say we've got here, this is our length, so this is this, and this is our width. So the length equals 2 times the thing that is the width. So let's get rid of those because they're going to throw us off. Okay, but let's start having a look at solving this equation. So if I've got 3x minus 4 equals this, the first thing I'm going to have to do is expand this bracket. So I know that 3x minus 4 equals 2x plus 2. Then what I've got to do is I need to get the x's on one side and the numbers on the other. So I'm going to start off by removing 2x from both sides. So I'm taking the 2x away from here. So I've also got to take away 2x from there. I'll take away 2x underneath like that to help. So 3x take away 2x leaves us with x. And then we've got x minus 4 equals 2. Then what we've got to think about is what number take away 4 equals 2. Well, we can get that by adding the 4 to both values. Or you could just think about it because that will mean the x equals 6. Because 6 take away 4 is 2. Now that we know that x is 6, we can work out the length of both these sides. So this one is x plus 2, so 6 plus 2 equals 8. So this side is 8. This side is twice 8, so this will be 16. Oh, we've got 8 times 16 again. They love this calculation. So now what we need to do is 8 times 16 to find out the area of the rectangle. So I'll put it like this, 16 times 8. So 6 times 8 is 48. 8 times 1 is 8. Add the 4 is 2. So that will be 128, and it's centimetres, so the unit will have to be centimetres squared. So here we go. Let me write that down here. 128 centimetres squared, 6 marks. Right, let's see if we got that correct. Oh, I've got it wrong. How have I got it wrong? 1 second. Oh no, I was so confident. Where did I slip up? Okay, 1 second, 1 second, 1 second. Right, so. Oh no! Oh, I see where I've gone wrong. Have you spotted where I've gone wrong? I'll give you a moment to have a quick look at where I've gone wrong. I'm going to kind of highlight the area. I've made a big mistake here. Okay, in the meantime, while you have a look at that, I'm going to multiply out these. I'll get rid of this here. Okay. Have a look. Okay, the place I made my mistake was here. When I multiplied my bracket out, I did 2x plus 2 because I forgot to do the second term. Okay, so I should have had 3x minus 4 equals 2 lots of x plus 2. Now 2 lots of x plus 2, when I expand that out, that should give me 2x plus 4. Okay, and then what I can do is I can do the same thing that I did. I can take away the 2x from both sides, which leaves me with x take away 4 equals 4. And then I can add the 4 to both sides. So that gives me x equals 8. Okay. So then if x equals 8, that means that this side is actually 10. And then this side is twice that, which is 20. And then I can do 10 times 20, which equals 200. Okay. And that gives us the correct answer. Okay. There we go. So I'll rewrite that down there. Okay. So that's 200 centimeters squared. Right. Okay. Let's have a look at the next one. Okay. So question 22. So it says here, a teacher is planning a theme day for 500 pupils at their school. The teacher asks the sample of 20 pupils from year 8 which theme they would prefer. The results are shown in the table. So sport, art design, recipes, music and movies. Describe 2 disadvantages to the teacher's sampling method. Okay, right, so 20 students isn't a lot of students. A small sample. And year 8 won't be representative of the whole school. I'll just add for 500 students here. I'm sure that's fine. Okay, part B, we've got using the results from the table, the teacher estimates that 175 pupils in the school would prefer a sport theme. Here is the teacher's method. 7 over 20 times 500 equals 175. Write down one assumption that the teacher has made when making their estimate. That the sample, is representative. Of the whole school. Okay, here we go. Right, so let's have a look at the answers to this to see what they put and we can compare. Right, so any 2 from small sample, limited to 1 age group, male, B, 1 gender. Yep, perfect. Okay, next, the sample is representative of the whole school. Very good. Okay, right. Let's have a look at the next questions. So here we go. The diagram shows a town T and a straight road AB. The scale says 2 centimetres represents 1 kilometre. So let's have a look. So a new road is built from town T to the road AB. The road is the shortest possible distance to town T, from town T to road AB. Using a ruler and a compass only, construct the road from town T to road AB. Okay, right. So it's going to be a bit difficult to show you this, but I'm going to just make the arcs that you would need. So you want it to go from, what we first of all want to do is, say we've got our compasses. We want to set a compass from town T, okay, like this, and we want to just go through road B, and we're going to want to swivel. We're going to want to swivel our compass, okay, like that, and then on the other place over here, so that we get 2 points on this line that are exactly the same distance away from each other and exactly the same distance away from town T. Okay, so they're the first points that we're looking for. They're the first arcs that we're looking for here. Now, once we've got this, what we do is we're going to measure our compasses so they match to point T, okay? And then what we can kind of do is we can think about it. We can draw an arc here, and then we can take our compass all the way down and draw an arc here that will be opposite it. Okay, so that's what will happen. We'll use this compass to draw a big line that goes like this. Then what we'll do is we'll move the compass. Okay, oh no. What we'll do next is we'll then move the compass to the other point. Okay, like this. Let's go black. I'll move the compass to the other point here like this. And then I'm going to do the same thing. And I'm going to draw another arc that goes all the way down like this here. So it meets at the opposite end of the side here. Now, if this had been accurate, when I then connect these 2 points, what I'll get is I'll get a lovely line that is clearly at a right angle to this line. So I can see that my points that I've drawn here, they're not accurate because they haven't made the right angle. But when you connect those 2 points, they should make a right angle here, which you'll be able to see if it's worked because you can recognise a right angle, or you could use your protractor. So what the examiner will want to see is they'll want to see all of these markings, well, not like mine, but they'll want to see all of your markings, and then they'll want to see that you've drawn the line straight from here. And then we can clean it up a bit. Okay, but don't clean it up too much because they will want to see the markings. Okay, so actually I will just clean this up and show you what the lines they'll want. Okay, so they'll want this line here, and then they'll want to see a line here, a line here, a line up here, and a line up there. So that's what the examiner is going to be looking for. Okay, now let's have a look at part B. Part B says Part B says the new road costs. It's a bit small. Part B says the new road costs £200,000 per kilometre to build. The new road constructor says the new road will cost over £600,000 to build. Show that the constructor is incorrect. Okay, so we know that 1 km equals £200,000. Okay, so he's saying if 3 km is going to be £600,000. Okay, one sec. So there we go. 3 kilometres would cost £600,000 because that is 3 lots of the 1 kilometre. So we're looking at, is this road 3 kilometres long? That's our question. Is this road 3 kilometres? Is it 3 km? Well, what we've got to do here is we've got to measure it. Okay, so 2 centimetres equals 1 kilometre. So let's say that we measure this, and it's difficult because I don't have a ruler. 1 second, let me draw a ruler. So let's say I've got my ruler here. I'm going to use my ruler. Okay, and let's line it up so that it starts at 0 here, and then we'll measure it. 1, 2, 3, 4, 5. and let's say that this line is 5 centimeters. Okay, well, if it's 5 centimeters, 2 centimeters equals 1 km. Okay, so that means that 6 centimeters will equal the 3 km. Okay, this line is only 5 km. Line is only 5 km. So it won't cost. Oh no! Oh no! I've gone really wrong. The line is only 5 centimeters. I've got wrong with my km and cm. Sorry. The line is only 5 centimeters. So less than 3 kilometers. So less than 3 kilometers. So the man is wrong. The road is less than 3 kilometers. So will cost less than £600,000. Okay, right. Let's check the mark scheme. The mark scheme will probably have the exact measurement for the line, which you could have achieved with the ruler. So here we go. Or that would be 6 centimeters on the map, but it only measured 5.2. Here we go. So that's the answer that we've gone with. Okay, there were other methods. You could have worked how much it would have costed to draw that line, to build that road at its length. Okay, right. Let's move on. Okay, here we go. We've got question 24 here, and this says that a straight line passes through the points 0, 5 and 2, 13. Find the equation of the line in the form y equals mx plus c. So we've got different bits here. So the c, you might recognise this, is the y-intercept. And the m is the gradient. Okay. So the y-intercept is pretty easy to get from here. It's going to be 5. So this will be y equals mx plus 5. Now, the gradient bit, you might have heard the phrase for this. The gradient equals rise over run. Rise over run. So it's how much has it increased, but divided by how much has it gone across. Okay. So the rise in this line between these 2 points, has gone from 5 to 13. So that is a rise of 8. So I'll put that here. So our rise is 8. Our run, it's gone from 0 to 2. So that is a run of 2. So the gradient is going to be 8 divided by 2. 8 divided by 2 is 4. So now that we know that this m part will be 4, we can write out our equation, and that's going to give us y equals 4x plus 5. Okay, right. Question 25. Find the value of m. So we've got 2 to the power of 7 times 2 to the power of m equals a half. Okay, right. So the first thing we've got to do is we've got to sort out this a half and write it as 2 to the power of something. So 2 to the 1 over 2, so this is like 1 over 2 to the power of 1, which means that this is 2 to the power of negative 1. Okay, so that is the first trick to this question. So we now know that 2 to the power of 7 times 2 to the power of m equals 2 to the power of minus 1. Now, the laws of indices state that if you're multiplying numbers with the same base that are raised to a power, then you can add their powers to get the total. Okay, if we think about it, it's like if you had 2 squared times 2 cubed, that would equal 2 to the power of 5, because this would be like 2 times 2. This bit would be like 2 times 2 times 2. So therefore, this bit is like 2 times 2 times 2 times 2 times 2, which is 2 to the power of 5. So that is that law of indices, that if you're multiplying numbers with the same base, you add the indices. So therefore, what we can do here is this tells us that if we've got 2 to the 7 times 2 to the m equals 2 to the minus 1, that tells us that 7 add m equals negative 1. Okay, so now what we have to do is we take 7 from both sides. So we've got m equals minus 1 minus 7. Okay, minus 1 minus 7 is minus 8. Okay, so m will equal negative 8. Right, let's take a look to see if those were correct, and then we will move on. Yep, so the first one was right, 4x plus 5, and the second one was correct as well at negative 8. Right, let's have a look at the next questions. We must be getting close to the end now. Turn over for question 26. Okay, so, oh yeah, this is page 20 of 20. Ooh, okay, right. Right, question 26 says, a triangle has sides of length 6, 10 centimetres and 12 centimetres. Is the triangle a right angled triangle? Show how you decide. Okay. Well, it is a right angled triangle. Let's just draw it out and presume it is. Okay, so we're going to have 6, 10 and 12. Now, the way that you prove a right angled triangle is by Pythagoras' theorem. So, and that is that a squared plus b squared equals c squared. So in other words, if 6 squared, oh no, it's not a right angled triangle. If 6 squared plus 10 squared equals 12 squared, then this would be a right angled triangle. So let's try it out. 6 squared is 36. 10 squared is 100. And 12 squared is 144. Well, I can see that they are not equal, okay? So therefore, this cannot be a right-angled triangle. So actually, it's not a right-angled triangle at all. So we're going to say no, because it does not follow the rules of Pythagoras' theorem. Okay, and we can see that there from the working out. So let's just check if they're happy with that as the answer and see what they've said. No, 144 is not equal to 136. Yeah, there we go. Right, okay, that takes us to the end of that paper. So thank you very much for joining me. As I said earlier, if you've got any topics that you want, I'm going to stick around for a few minutes and I can go through some of the questions again if you want, if there's a topic that you'd like a little bit more work on. I am more than happy to do that. But first of all, I'm going to be back in 1 second. And if you think of anything, just write it down and we can have a quick look. Okay, cheers. Hello. Okay, I'm back. So yeah, if you've got any questions, any topics you'd like me to go through, just let me know and I will happily do them. If not, I'll just sit here for a little bit until you're sure, and then I'll go. Okay, great. Right. Thank you very much. Bye.